This here is some brand new electrical solder, and what I would like to attempt today is to extract some silver out of it. You see, not too long ago, I flipped to the back side of one of these protective wraps to look at the ingredients of this solder, and to my surprise, the back label stated that the product contains tin, copper, and most importantly silver, as well as some rosin. What it didn't say, however, was how much each one of these it contained, and honestly, I could have probably just looked it up. However, I decided to get a new one and do a bit of chemistry to find out myself. To do that, I first need a beaker, and while here I'm using a 100ml beaker, later on you will see that this volume wasn't enough. To start off, I will need to dissolve the tin contained in this alloy, which probably accounts for around 90% of this lead-free solder. The best acid to use here is hydrochloric, since it won't touch the silver as well as the copper, with which I can deal later on. As soon as I added the acid, the tin begins to dissolve, and despite the fact that this amount of acid wouldn't be enough, I decided to let it react for a while before moving everything into a larger beaker. On top of it, I decided to add a bit more fresh acid, as well as heat up the solution to speed things up. After about 30 minutes, most of the acid had reacted, and here you can see that at the bottom, we now have a small amount of our silver precipitate, as well as some of the rosin stuck to the walls. To keep dissolving, I discarded the tin chloride solution into a waste container, and once again, I added more acid. This time, however, after getting things boiling hot, the majority of the tin had dissolved, and I can now filter everything through a Buchner funnel to get rid of the residual liquid. What I want to do next is to remove any copper that is present here, and to do that I want to use dilute nitric acid, which will dissolve the copper quite well, but not so much the silver. To do this, I simply mix azeotropic nitric acid with water in a ratio of 1:9. As you can see, not much is happening here, and that is because the amount of copper in this alloy is anywhere from 0.5% to 3% by mass. Either way, I let it sit around for about 15 minutes, and afterwards I filtered everything, making sure that the powder came out as dry as possible. Next, I transferred everything into a crucible, and the first step is to burn away the paper. It's important to do the initial burning carefully and with a low flame so that some of the silver particles don't get ejected out of the crucible. About halfway through burning up the paper, I began to notice that the flames were giving off a vibrant blue color. This is most likely due to the copper ions that were coming off of the decomposing residue of copper nitrate. Once I got to the point where I had mostly silver and some ash left, I decided to add a little bit of borax to help collect all of the junk, as well as let the silver come together into a single droplet. At this point, you can already see the small silver droplets. However, to help them join together, I decided to mix everything around with a graphite rod. Next, I preheated the mold and quickly poured my silver into it. This little piece came out to weigh around 6 grams, and to really make sure that this is silver, I decided to determine its density by the water displacement method. As you can see, the volume of this piece came out to be around 0.65 milliliters, and according to the density formula, its density should be around 9.12 grams per milliliter, which is pretty close to the actual 10.29 that of pure silver. The difference is likely caused by either the residual tin or simply by the fact that I had to eyeball my volume measurement. By the way, getting silver this way isn't very efficient, and if you need some for a different project, I would highly recommend that you buy it. Now, I could probably turn mine into a silver bullet to protect myself from vampires, but I would rather just add it to my element collection. Anyways, I hope you enjoyed, and see you next time.